Welcome back to section 6. We were in the middle of example 9, and so in the last video we ended with determining that the empirical formula for this particular problem was C4H9. And remember, what does empirical formula mean? It's telling you the lowest whole number ratio for elements in a particular compound. So all this tells me is that whatever compound this is, it's going to have a 4 carbon to 9 hydrogen ratio. Now, what's the molecular formula? I don't know. Maybe the molecular formula actually is C4H9. But maybe it's double that. Maybe it's actually C8H18. Maybe it's triple that. Maybe it's C12H27, and so on and so forth. We need to figure that out. So that's the second part of the problem. So what I'm going to do is I'm going to go ahead and clean up this space a little bit. There we go. Gives us a little bit more space to work in. And so we left off figuring out that the empirical formula, let me get rid of a little bit more. There we go. We left off figuring out that the empirical formula for this unknown compound was C4H9. Now what we need to do is use this information along with the fact that we know the true formula has a mass of 114.2 grams per mole in order to determine what the molecular formula is. Now before we do any math, I want you to understand, once again, what are we trying to solve for here? We know that the molecular formula has to be multiples of 4 to 9. And so we gave some examples over here to the side, right? So we said, okay, it could be any of these and so on and so forth. So we know that from a logical standpoint. We need to figure out what multiple that is. Think about it. If the empirical formula was the exact same as the molecular formula, then wouldn't we expect their molar masses to be the same? Correct, we would think that. But if the molar mass of the molecular formula is double that of the empirical formula, then that means the multiplier would be 2. Or if the molar mass was triple what the empirical formula molar mass would be, then that would be our multiplier here. So really, this last step is actually very simple. So here's what we do. We say, okay, we know that the true molar mass is 114.2 grams per mole. Let's compare that to what is the, so I'm going to put M for molecular. E is going to stand for empirical. What is the molar mass of our empirical formula, C4H9? Well, let's figure that out. Carbon is 12.01 times 4, plus hydrogen is 1.01 times 9. The molar mass of the empirical formula is 57.13 grams per mole. So simply by comparing these two, is this a case where the empirical and the molecular formula are the same? No, there's no way, because they're not the same molar mass. But if I took 114.2 grams per mole and I divided it by 57.13 grams per mole, I end up getting roughly 2. What is that telling me? That's telling me the true molecular formula is double the empirical formula. In other words, the multiplier is 2, and that means the molecular formula, the real formula, is C8H18. So that is the true formula, whereas the empirical formula is C4H9. I'd like you to do one example on your own. Go ahead and pause the video and try to do this problem on your own. Then hit play to reveal the answer. Alright, so I've got some of the work shown here. So starting off with our percentages, we actually know the percentage of nitrogen, so that's here. Oxygen's percentage was not given, but we could figure it out by simply taking this percentage subtracted from 100. So our percentages for nitrogen and oxygen are given. Assuming we have a 100 gram sample of both, we can convert these percentages to grams by just dropping the percent sign and adding the grams. Next, I want to take those masses and I want to divide them by the molar mass for each element, so that way we can convert that to moles. So when we do that, the number of moles for nitrogen is approximately 2.63, and the number of moles for oxygen is approximately 3.95. At this step, compare the two number of moles and divide by the lowest. So 2.63 moles is the lowest, so I'm going to divide all my answers by that value. And so obviously that's going to give a value of 1. What do we get when we take 3.95 divided by 2.63? We get 1.5. So that's saying that my subscripts are N is 1 and O is 1.5. But remember, we can't keep that, and we don't want to drop or round this to 1 or 2 because that's too much rounding. So ask yourself this: what is the fraction form of 0.5? It's 1/2, right? So that means we're going to multiply both these numbers by the reciprocal, which is 2. So multiply that number by 2 as well as that number. So that means our subscript for nitrogen ends up being 2, and our subscript for oxygen ends up being 3. So our empirical formula is N2O3. And that's all we have to solve for, because this problem does not ask us to solve for the molecular formula. Last bit of practice here. This is not necessarily in your notes, but just a good practice to do together. Write the empirical formula for the following compounds. Remember, empirical formula is the lowest whole number ratio. So for this first one, the lowest we can reduce that is C4H9. That was actually one of the problems we did together. And then this one right here, if I were to reduce all of these down, it would be CH3O. That would be the empirical formula for these two. And then this last question, it says a compound with an empirical formula of C4H4O and a molar mass of 136 grams per mole, what is the molecular formula? So first thing I'm going to do is figure out what is the empirical formula's molar mass. So 4 carbons times 12.0401 plus 4 hydrogens, so 1.01 times 4, and then plus the mass of 1 oxygen. This molar mass for this compound right here is 68.08 grams per mole. If I compare that to the molar mass of the true formula, obviously they're not the same. But it looks to me like the true formula is about double what the empirical formula is. To verify, I just simply take the molar mass of the true formula divided by the molar mass of the empirical formula, and this will get me my multiplier. This should come out to a whole number, or pretty darn close. And when I do that, I get 1.997, which essentially is 2. That means the true formula is double what the empirical is. So if the empirical is C4H4O, the true formula is C8H8O2. All right, that wraps up not only section 6, but topic 2. We'll see you in the next topic.